Hi, everybody. Thank you very much for having me. I'm Iñaki Villar, build engineer at Tinder. And yeah, so this presentation is called Scaling Android Builds in Pandemic Times, because since everybody was moved to, well, was forced to work from home since the pandemic started, at Tinder, we try to analyze some ways to improve the developer experience in a scenario with a high volume of change on the main brands and massive modularization. Some developers are working in some specific features, and then when they are pulling the change from the main branch or from the repository, they are going to have to compile and to execute again, well, different parts of the build because they don't have the change. We found that caching is the most simple and effective way to improve the performance, and this talk is focusing on remote caching for our build system, Gradle. First of all, as introduction, we need to understand how it works internally from the build system perspective. So imagine that in your Android project, you need to execute your build, and your build needs some dependencies to build, right? So that's what we call the build dependencies. That's like the Gradle version, the Gradle wrapper. We need some plugins because we are working with Android, and we need the Android Gradle plugin and the Kotlin Gradle plugin. And additionally, some of the build scripts are going to add an additional build dependencies too. If we are talking about the dependencies of runtime and compile configurations, in the Gradle, we need some dependencies. So that's the things that we need to build. Okay, once it's built, we are going to, well, Gradle is going to generate an output. This output contains all the artifacts and the results of the different tasks. But as well, Gradle is storing in the Gradle folder under your user properties different information or different dependencies that we have used in the build. Meaning that once we are going to build again, so we don't need to download again the Gradle wrapper, or we don't need to download the Gradle plugin and the dependencies like Dagger that you are using. So in the moment that we are using a Gradle clean, we are going to remove the output of the build, but still we are going to use the dependencies that previously we have stored in the Gradle property, in the Gradle folder. Additionally, to this mechanism, there is something that is called the local cache. And the local cache is coming not from the dependencies and not from the artifacts itself, right? The local cache comes from the outputs of the task. Gradle is a build system based in tasks, like many other build systems. And we are going to store there the output of one task, meaning that once the build is finished, we can have those different outputs there. And the most important thing, we are going to store not only the current state of the project. Imagine that you are switching between different branches. You can store different states for the same output of the task. And how is working internally from the Gradle perspective? So as we mentioned, Gradle, the task of Gradle is going to generate an output. But to calculate the key, meaning that to calculate if something can be reused from the previous build, means that we need to have some common values. For example, imagine that I want to reuse the previously assembled task calculated, so the inputs of the property of some condition has to be completed. In that case, Gradle is going to compose different cache items for all the items, all the inputs of the task itself. Some of these inputs, to have like more clear perspective, is, for example, the GlassPath. Another point is the build step components. Every time that you are updating, for example, the Android Gradle plugin, there are some tasks that they are going to generate a different output, meaning that I cannot reuse these task outputs. The same with the output properties that we are defining in the task. And something that is as well important is the build script when affects the execution of the task. Here is something that we have asked ourselves all the time. Imagine that you have 100 modules and you are updating one build Gradle. That means that this change on the build Gradle is going to have an impact on the task. Well, only if the build or the task of the task executed, the build script affects the execution of the task. Finally, you are going to compose all the different keys calculated for each of the inputs, and you are going to generate a key for all the elements. So again, that's how Gradle identifies that one task can be reused or can be used as from cache from a previous build. And that's something that is starting to be more cool because, first of all, when we are doing a Gradle clean, we are removing the output of the project, but still we have the local cache available and we can retrieve the values. That's something that the local cache survives not only to the change of branches, but as well to the clean. Additionally, to the local cache, we have the remote cache. The remote cache, the fundamentals are the same, but instead of being local in your own machine, are going to come in from a third part, like from a remote caching. It works like similar. So the remote cache is going to store different outputs from different tasks in the cloud. Once you are doing like a completely clean state, imagine that you are starting from a scratch a project or you have removed everything, the thing that still persists is the remote cache. And that's something that is cool because we are going to save the time calculating and we are going to decrease the pressure of memory in our machines. So we have two types of caching: the local cache in our local environments and the remote cache. The remote cache can be whatever you want. We have the typical build cache node. We have the built-in node that's coming with Gradle Enterprise. We have Redis, or we have S3, whatever you want to use as persistent solution in the cloud. We are not going to enter in the implementation details here. To configure a remote cache, it's quite easy. The build cache configuration from Gradle API is going to add this specific closure to update the configuration. This HTTP build cache is a common object from the Gradle API that allows us to define when we want to push what is like the URL and some kind of authentication too. The other hand, if you want to use a custom S3 implementation, for example, the build cache as well is adding, the build cache configuration is adding a possibility to register different cache services. Like here, we are registering our S3 instance, and we are going to later to configure under our requirements. And what else we need if we are working with a different implementation? So caching is not something new, and we had caching like different years, different plugins. I remember years ago working with the American Express plugin, but even in Tinder, we have created our own plugin because of requirements. But I would say that, well, the last one, for example, the Gradle S3 build cache is quite recent and adds some statistics to the usage of the remote caching too. And finally, we have to say, what is the strategy of caching? One of the, I would say that the basic configuration is having on CI, every commit on the main branch is going to trigger the action of populate the remote cache. And later, the local builds are going to enjoy or consume these elements of the build cache. Again, this is a basic setup and would be like something to start perfectly. But again, everything that we have seen now, it's not something new. That's something that, well, I remember maybe 3 years ago working with caching too. So that's something that we have done during the years. But the real key concept in the caching is how we can optimize and better how we can identify some of the problems of caching. Because the scope of this talk is with big projects. And in big projects, we need to optimize the remote caching. It's not enough to do a basic setup. We need to understand why we are having problems with the cache. To have a better understanding, let's take this example when we have a project with 9 tasks. Remember that Gradle is a dependency, a cyclic graph build system that is going to combine different tasks. Once we apply the remote caching in a clean state, we are going to have something like this. So far, so good, right? But in another scenario, and that's more close to the reality, when we have thousands and thousands of tasks, when we apply the same behavior in our local machine, we're going to have this a scenario, and in numbers represents that we are hitting 99% of the possible tasks that can be cacheable in a 30 minutes. So it's something that could be good, but still, I don't think that times like this are going to be good, right? One thing that we can try to understand how bad or well, what's the level of our problem is apply the same test in a CI build. If we apply the same in a CI build, we have a 100% of hit ratio with 3 minutes. So totally 10 minutes of difference. That's a lot, but that's perfectly normal. Imagine that you have your huge project with a massive modularization, and I'm talking more than 500 models. So we have a lot of developers trying to update different parts of the application. That means that the lower parts of the project are going to be more sensible to be affected by the change of the upper task. And imagine in your own project that you have to execute the KAPT or the compile Kotlin task from the main entry module. It's going to take a while. And that's the thing that we want to investigate and see from where comes these problems. First of all, the first approach that we can do is comparing the builds, CI build and the local build. To do that, we are going to use the build scans. That's a feature from Gradle. You have the Gradle Enterprise and the free versions of the build scans. And you have to go to the performance build cache section, and it's going to tell you what's the different levels of hit for the local and remote caching. You have to use that just scan if you want to include in your build configuration for that. We have for the CI build that we have requested 6,000 tasks. And the first thing in our case is that we are disabling the local cache for the CI builds. So we want totally clean remote builds from the CI perspective. But we have like a very good number. So that means that this is the perfect scenario. If we do the same in the local build, we generate the build scan, we can see on the same section that as well we have these differences. So we are using the local cache with 2,000 tasks and the remote with quite good numbers, but still we have 50 missing tasks. The build scan has in the lower section, once you have like in the header, you can see the hits, you can see as well what operations or what missed tasks you have performed in your build. And we see that, well, we have missed the KAPT library models and the compile debug the same, right? So meaning that, well, we have a problem there, but we don't know how to fix it. In Tinder, we are using Gradle Enterprise, and the product allows to compare build scans, meaning that, for example, if I want to see what's the problem that I have with CI, I can compare both build scans, and I can go deeper to understand better the problems. To apply that, first of all, you have to go to your build scan. You're going to click. It's going to show another screen with the possible candidates to compare. I'm going to select the CI build, and then I'm going to have like a screen like this, a user interface like this. The comparison of the build scans are separated in different sections. For example, we have the infrastructure. There we can see the differences between the different builds. One, in my case, is built by macOS, and another is built by Linux. So it shouldn't be determinant that we have different OS, because at the end, the output is agnostic. The output of the task should be agnostic of the operative system. But maybe imagine that you are using another investigation that you are doing. Maybe one developer is using another version of the JVM. Could be here where you're going to find the problems. Another section is the switches, the Gradle switches. That's a common practice that, well, maybe we have we have like the same switches in the Gradle configuration, but it's possible that somehow or somewhere somebody has a different values. And it's here where you're going to find the problems. The build dependencies and dependencies are quite clear, so they're going to show the differences. But in terms of the task inputs, we are going to have this screen, right, where we are going to compare both bills, but we have a message. And this message says that it cannot be possible to compare the bills in terms of the input task because we are not capturing the task. To do that, we need to apply in the bill scan configuration the property is capture task input files, or if you want, you can add in the command for your build. This is going to generate a screen like this. Well, we have to repeat the process again. We have to build our execution. We have to do the same in CI with these properties and compare again in the Gradle Enterprise. This screen, the comparison is going to give us the information about the different task differences. We can filter out then, and we are going to give investigation case for our example. In our case, we have seen that we had 50 missing tasks. We want to understand what's the origin of these differences. One of the tasks that was not hitting the cache was app compile flavor debug Kotlin. And it's going to contain this kind of entry in the build scan configuration. There we can see, first of all, the cache key is different for both tasks. That's something that we know. And the outcome is as well different from cache in CI success. How we can understand? The next section is the differences that we find in the file properties or the value properties of the inputs that they are considered to calculate the key of the task. If we click there, we can start seeing where are located the differences. Here, for example, we can see that, well, it's in the debug flavor build config configuration where is coming the difference, but we can go deeper. Every dot that you are seeing on the screen represents one of the build variants of the comparison. If we click again in the flavor debug, we are going to see specifically, we are going to see where is the problem. And the problem for the use case that we are talking is some differences in the build config configuration, the build config Java configuration. And that's something that was normal in our case, because on CI, we were trying to build with a specific property. And this property was not enabled in the local build, meaning that the content of the build config is going to be different. And with this simple property, addition of the property in the build, this is going to cause that the remote caching are going to be like, the remote caching are not going to be hit. In Tinder, thanks to Gradle, we had a very long investigation to understand better our Cashmisses in a project. Again, in a big project, it's very important to understand this section. The typical use case that we have, and I think that yesterday Nelson commented, it was about the empty folders. Empty folders that, for example, in your workspace exists one empty folder and not in CI. So again, if your project has a high volume of commits, and with a high number of developers, it's normal that your workspace locally could be in a bad state, meaning that maybe you have some stale files or some stale directories that doesn't correspond with the reality. And as basic as this, if you remove all the directories, empty directories in your local version, it's going to help you with the remote cache. Yesterday, Nelson commented that maybe in 6.8 or maybe in the future versions, this problem is going to be fixed and Gradle is going to take care about these problems. But again, think about how old is your base code. Maybe you haven't moved from your local workspace since 1 year ago, and that means that maybe you have shared some empty folders, files that doesn't exist in the remote repository, and you can do the test. Another problems that we found on Tinder was this example. One developer had maybe like hundreds and hundreds of tasks that were missing to the remote cache. And we proceed with the investigation, comparing the build scans, and we saw this difference. on CI, we had a difference in the class path regarding the local build, meaning that the version or the content of the Android jar was different, and it was very strange. And the reason for that, it was the developer was using Android preview version. Well, you know that typically when it starts Android or when a new version is coming, you install the preview and never was updated. And for this simple case, this developer was not enjoying the remote caching. So thanks to this investigation, we were able to help and fix this problem. Another case that we've found on Tinder, it was well quite special. So again, one developer with a lot of different misses in the remote cache, and we were seeing a difference in the SHA of one library. So it was totally impossible, right? So because you were like checking what is the SHA of the repository current dependency, where was, and it was correct in terms of CI, but the developer had a different version, and we started the investigation, and we ended with this problem in the repository itself. So where there was like different versions of the artifact deployed in the repository. And the developer had the bad luck to have the dependency at that time that was different from the one that we were using after that. So again, they're like, can be a little bit hard sometimes to investigate the cache misses, but it's quite important to understand and how can improve when you resolve these issues there. If you want to know more about how to investigate cache misses, Nelson, that actually is working in Gradle, has these two great articles about how to investigate the cache misses in your builds. But it's fair to say that not everybody is using Gradle Enterprise, and maybe you want to investigate too, and it's possible. So if we take an example, the GlassPath problem that we saw before, we can have something with this flag to investigate more. This flag is going to generate the output in your build about the different properties or the values for the different inputs for a given task. For example, for this task that is called generate debug build config, we have these inputs that are important for the cache key calculation for the task. That's, of course, as you can see here, very coupled with the Android Gradle plugin. We have the flavor names, the library, the version code, and then the output is going to tell you what's the hash calculated for these fields. And at the end, we are going to have the content of the composing all the different hash keys for the task itself. So one way to trying to solve or to understand this problem, and of course that you need to automate, is again generate a CI build with the flag of debug caching for both a local build and CI build. Then we can pick the different inputs that they are going to be important for the calculation of the task, and we can try to match where is coming the problem. And here it is, the same input or the same property that this class path is failing once we are comparing with a local manual comparison like we're doing with Gradle Enterprise. If you are building with Mac and your CI is Unix, you will see that it's quite hard trying to achieve the 100% of the remote cache hits that we are seeing, for example, in an Linux machine. And it's possible. For example, once I have optimized my remote cache or my local build, I have aligned my local version of the repository with the upstream, we are still seeing some tasks that they have some differences. And you start again doing the process to comparing the builds, comparing the outputs, and it's not clear how to fix these problems. To fix these problems, and they're related with the Android Gradle plugin, we have this plugin coming from Gradle that is called Android Cache Fix Gradle plugin that is going to add some workarounds for some tasks before are merged in the under-Gradle plugin these fixes. So, well, meaning that, for example, in our case, that specific case that I have problems with the compile debug library resource, applying this plugin or checking this plugin, I see that there is a workaround for the 4.0 under-Gradle plugin version. And applying this plugin in my project means that I can hit the cache there. So usually when you are updating the new version of under-Gradle plugin, there are like new improvements, but maybe there are some tasks that you can have problems. Take a look of this plugin and you will check and you will see what are you will increase the hit, the remote cache hit for this task. Okay, so once we have learned how we can try to analyze better the builds, it's moment to go a little bit one step forward, right? So if you think from the caching perspective or for the caching concept of computer science, we are just in a corner, meaning that from the Android perspective, we are just fetching or we are pushing elements in the cache. That's it. So we are not entering in complex hierarchies or complex things. But still, so there are a lot of room to improve our builds applying some concepts of caching. On the first section, we saw that the typical build environment to populate the cache is where one commit on the main branch is going to trigger the remote cache, it's going to populate the remote cache, and then the local developers are going to enjoy the output of this task. But not everybody works on the same way. For example, we have this typical scenario where you have an external built environment and internal built environment. The external built environment could be a CI provider, Circle CI, Travis, GitHub Actions, whatever. And then you have your internal built environment where you don't have any connection between the possible caching that you are going to enjoy from CI in your remote caching. Also, of course, once you will try to do some kind of hooks with the repository, you still can populate the job. If you have like a secondary Jenkins system in your internal built environment, means that you can still do a hook and populate the remote cache. But still, the CI is going to be totally independent. And something that we tried in Tinder is trying to speed up the CI process only with the remote caching. Somehow, imagine this picture where we have parallel CI build executions, meaning that maybe like 20 or 25 builds can be concurrent at the same time. We implemented build cache, and we didn't have any restriction in the main branch or when it has to be populated, the cache, or when it has to be consumed. Always the build cache, a remote cache, was enabling for all these steps. And we implemented this approach with S3 bucket, as simple as is. Our external CI provider is Circle CI, and we tried to put very close, or well, we analyzed how was like the beneficial to use instead of AWS, instead of using Google Cloud, and we choose AWS closer to our Circle CI provider because Circle CI as well is in AWS, and apply some security compliance aligned with our security department. For example, we were using like the assumption roles, and we were using encryption for our items in the remote cache. And something as simple as this speed up a lot our process in our build system. That's the result. So previously, and that's the truth. So once you are growing in terms of models, so the resources are going to, well, you are going to need more resources in terms of CI. The task operations, the test task operations are quite expensive. And if you're going to have some leak with Mockito, with Roboelectric, and so on, so you're going to consume a lot of memory. And we had this problem. So we were struggling a lot with the test task configuration. We went very conservative while we were growing in terms of models. We tried to minimize the number of workers working, that's increase our time. But once we implemented the approach of using the S3 build cache, we went down up to 20 minutes. And it was something good. And the most important part is after that, and this is from the last 3 months, we were able to stabilize the time for the main branch for independent of the number of modules. And that now maybe we are like with 600 modules and still we are enjoying the same time as 3 months ago. So quite interesting. Another benefit is that some models, some business models of, for example, Circle CI, they are, well, you can use different kind of instances. These instances are bigger or less bigger. Using this approach with build cache and remote caching means that your instance is not going to work or is not going to have this memory pressure, meaning that you can downgrade the instance that you are using. Instead of using a 2x large, you can use an x large, saving credits or saving money, because as well, you are trying to save the operation there. And another interesting approach, experimental approach, would be this one too. We say that once we have a new commit in the main branch, well, we are going to start a process, and this commit is going to populate the cache. And for a given task X, we have this output. The theory of the things that we have seen before is that the local build, once is going to pull the change from the main repository, is going to have like the output of the task from the remote cache. And that works, right? That's how it works. And we have like the same elements. But that's not, I think, the normal use case. Usually we have this situation where we have a new commit in the main branch. We have a given hash value for a task, a cache key, but the local build contains change as well. And the same task is going to generate a different output. And this different output is translated to a different cache key. So once the developer is pulling the change from the repository, we are not going to enjoy the remote cache. And as well, the combination of the differences of both the delta of both tasks are going to generate a new one. And how we can try to improve this? Of course, now or today, we cannot predict the future, right? Or we cannot anticipate what are the movements that the developer is going to say. But maybe we can think more simpler things. And one thing that we know is that there are some kind of changes that are related to the build stack. The Gradle version, the under-Gradle version, the Kotlin Gradle version, and the build source. And the most important thing, that we know that those changes are going to invalidate the cache. So we ended with a mixed solution where we are going to update some of the elements of some build component. We are going to analyze, or we are going to get the latest pull request, maybe the latest 40 pull requests pending. We are going to merge the change of the build stack components, and this is going to generate different outputs for a given task. And we are going to store these values, meaning that the developer or the different developers are going to enjoy the different values from the remote cache because we have pre-populated the values the day before. Usually how it works or how we implement it is that we wanted to minimize the updates on the build stack components because we know that they are going to invalidate. But once we have a pull request that contains an update of Gradle, we are going to start this process of pre-populating the cache with a combination of the different pull requests. And we measure this new process, we measure, and we had some results, and it was working well. So in this is the Gradle Enterprise user interface where you can see some avoidance savings, and we can see how much time we have gained in terms of the remote build cache. And we see the peaks after the days that we were following this process. So the hypothesis worked. So we can try to anticipate this kind of change. We can pre-populate the cache, and this is going to have a benefit at the next day when the developer is going to retrieve the results. And the most important part is going to, well, it's opening doors to think in more clever ways that how we can pre-populate this cache in there. And yeah, so this is the end of the talk. First of all, I want to thank my team in Tinder. So the Android developers there, they're awesome. So they're always helping, trying to give some suggestions, but to give thanks to Sami, of course, to coordinate everything. And additionally, I want to thank all these people. Maybe they are not aware, right? But so working on from the build perspective in the build engineer in big projects is quite challenged, right? And one cool thing that I really enjoy is how people try to experiment with new things, far from the conventional ways, right? When you have 1,000 project models, you have to try to think how to improve the experience, not only in terms of the build times, not only in terms of the CI, but as well in terms of the local development too. And yeah, so that's it. This is my Twitter user in case that you have any questions, so on. And now I think that we have 4 minutes left for questions. Well, anyways, to mention that the future is, looks very well, right? So in terms of caching, for example, we are going to enjoy the configuration cache that is going to be in the Gradle plugin for 2, already is in Gradle. As well, we have the file system watcher that has been improved in the version 6.7.1 that was released this week too. And if you notice, I have like one question. How do you configure the PR application? Well, we have like a process, and this process is going to set up with a custom script that is going to retrieve the latest PR from GitHub, and we are going to do different types of merge of the brands, and we are going to do the building of the main task for the entry point. That's going to generate a different output for the task, and it's going to push to the cache. So, I was saying that, we have like the file system watcher as well in the Gradle 6.7.1. And if you notice, all the solutions are going to be based in caching too. What is the most challenging task that you had to do during busy weeks of constant delivery? Well, so I remember having problems with Docker, Java 8, and Linux, and it was like a nightmare, because in terms of the memory, when you have some memory pressure in terms of Docker with Java 8, so you are not going to have like a heap memory error. So Gradle, or the container is going to kill your Java instance, and you don't know from where it comes. So, yeah. Did you manage to test configuration cache? I tested, but I tested in an Android project, and the Android Gradle plugin, I was testing for 1 or 401, it was not ready. So, but yeah, how much did that improve? Well, I don't know, but imagine that yesterday Nelson said the typical configuration time for 100 modules is around 10 seconds. So imagine for 500 modules, it's not linear, the growth, I can tell you. So we have situations where the time spending in the configuration time is bigger than the execution time. So we cannot be more excited about this feature of the configuration time because you are going to save all this time. Thank you. And yeah, so again, so exciting times are coming in terms of the build systems too. Thank you, Raul. Yeah, yep. Well, regarding your question about Java 8 too, well, we moved to Java 11 and we don't have this situation because Docker has a better integration in terms of the JVM arguments in the JVM arguments applied to the memory consumption, and everything is okay. But yeah, I remember hard times with Java 8, Docker, and Linux. Okay, anyway, so if you have more questions, thank you. Okay. Thank you very much. Thank you very much, everybody. And if you have any questions about the caching, about build systems, so on, that was my Twitter there. And yeah, thank you very much, everybody.